Hello friends, I'm Jagdish Perk Associate. Today's topic is thermodynamics. So in thermodynamics, I will be explaining a numerical problem from the chapter Work and Heat. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. First, I will read the question. A piston cylinder mechanism containing a fluid as a steering device as shown in figure. The piston is frictionless and held against the fluid by atmospheric pressure of 101.325 kilopascal. The steering device is turned 10,000 revolutions with an average torque against the fluid of 1.275 Newton meter. The piston is 0.6 meter diameter and it moves by 0.8 meter. Calculate the net work transfer. Now I will analyze the question. There is a piston cylinder arrangement as shown in the figure. So this is the picture of the piston cylinder arrangement. The piston cylinder arrangement consists of piston, cylinder, fluid and steering device. The cylinder is the container and the finite quantity of matter inside the cylinder is the fluid. So the fluid will be considered as system. The piston is the sealing component for the cylinder. The diameter of the piston is 0.6 meter. The piston is movable and frictionless, which means there will be no resistance offered in the movement of the piston. Initially, the position of the piston is maintained stationary against the fluid by the application of atmospheric pressure of 101.325 kilopascal. The steering device inside the cylinder is turned by the means of electric supply. So the rotating speed of the steering device is 10,000 revolution. And the torque produced for the rotation of the steering device is 1.275 Newton meter. Now we will see the working procedure of the piston cylinder arrangement. When the electric supply is on, the steering device starts rotating at a speed of 10,000 revolution, which in turn steers the fluid. Due to the steering action, the fluid will exert pressure on the piston. So due to this pressure, the piston will move through a distance of 0.8 meter. So in this question, we have to find the amount of work done in moving the piston through a distance of 0.8 meter. Okay. In this question, the movement of piston takes place due to the action of steering device and fluid. As I said earlier, the fluid is considered as system and the fluid is being steered by the steering device. So we can say that work is done on the system because the fluid doesn't steer by itself. The fluid is being steered by the steering device. To be more precise, the work done by the steering device is applied on the fluid, which means the work done is applied on the fluid or work is done on the system. Okay. Due to the steering action, the fluid will develop pressure automatically. So we can say that work is done by the system because the pressure is being developed by the fluid. So the formula for the total work done in moving a piston through a distance of 0.8 meter is equal to work done on the system for steering the fluid by the means of steering device plus work done by the system for the automatic development of pressure by the fluid. Okay. Now I will list out the given conditions. First is atmospheric pressure and the value is 101.325 kilopascal, which is taken as P. The speed of the steering device is 10,000 revolution and it is taken as N. The average torque is 1.275 Newton meter and it is taken as T. Diameter of the piston is 0.6 meter and it is taken as D. The distance moved by the piston is 0.8 meter and it is taken as L. So by using these five conditions, we are going to find the value of the total work done in moving the piston through a distance of 0.8 meter. Now I will move to the solving technique. First we will find the value of area of the piston, which is taken as A. The formula for area of the piston is A is equal to pi by 4 into D square, where D is the diameter of the piston and the value is 0.6 meter. So the next step will be A is equal to pi by 4 into 0.6 meter whole square. In this RHS, 0.6 meter whole square is 0.36 meter square. So the next step will be A is equal to pi by 4 into 0.36 meter square. So pi by 4 into 0.36 meter square is 0.28 meter square. So the next step will be A is equal to 0.28 meter square. And consider this one as equation 1. So the area of the piston is 0.28 meter square. Next, we will find the value of work done by the steering device which is applied on the fluid, or work done on the fluid, which is taken as W1. And the formula is W1 is equal to minus 2 pi nt. The negative sign indicates the work is done on the system. Okay. So in this RHS, N is speed of the steering device and the value is 10,000 revolution, and T is torque applied on the steering device and the value is 1.275 Newton meter. So the next step will be W1 is equal to minus 2 pi into 10,000 into 1.275 Newton meter. In this RHS, minus 2 pi into 10,000 into 1.275 Newton meter is minus 80.11 into 10 power 3 Newton meter. So the next step will be W1 is equal to minus 80.11 into 10 power 3 Newton meter. So in this RHS, 10 power 3 Newton meter is kilojoule. So the next step will be W1 is equal to minus 80.11 kilojoule. And consider this one as equation 2. So the work done by the steering device which is applied on the fluid, or work done on the fluid, is minus 80.11 kilojoule. Now we will find the value of work done by the fluid or work done by the system, which is taken as W2. And the formula is W2 is equal to PdV, where P is the atmospheric pressure, dV is the differential volume. The formula for differential volume is area of the piston into distance moved by the piston. Area of the piston is taken as A and the distance moved by the piston is taken as L. So dV is equal to A into L. So the next step will be W2 is equal to P into A into L. Consider this one as equation 3. Now substitute equation 1 in equation 3. What is equation 1? Equation 1 is area of the piston and the value is 0.28 meter square. And in equation 3, P is the atmospheric pressure and the value is 101.325 kilopascal. And L is distance moved by the piston and the value is 0.8 meter. By substituting equation 1 and the P and L values in equation 3, we get W2 is equal to 101.325 kilopascal into 0.28 meter square into 0.8 meter. In this RHS, kilopascal is 10 power 3 Newton per meter square. So the next step will be W2 is equal to 101.325 into 10 power 3 Newton per meter square into 0.28 meter square into 0.8 meter. In this RHS, split the numerical terms and SI units. We get W2 is equal to 101.325 into 10 power 3 into 0.28 into 0.8 into Newton per meter square into meter. Here 0.28 into 0.8 is 0.22 and Newton per meter square into meter is Newton meter, because meter square gets cancelled. So the next step will be W2 is equal to 101.325 into 10 power 3 into 0.22 Newton meter. In this RHS, 101.325 into 10 power 3 into 0.22 is 22.91 into 10 power 3. So the next step will be W2 is equal to 22.91 into 10 power 3 Newton meter. In this RHS, 10 power 3 Newton meter is kilojoule. So the next step will be W2 is equal to 22.91 kilojoule. And consider this equation as equation 4. So the work done by the fluid or work done by the system is 22.91 kilojoule. Next, we will find the value of total amount of work done in moving the piston through a distance of 0.8 meter, which is taken as W. And the formula is W is equal to W1 plus W2. So in this formula, W1 is the work done by the steering device which is applied on the fluid or work done on the fluid. And W2 is the work done by the fluid or work done by the system. We know the values of W1 and W2. Just substitute the values in this formula. We get W is equal to minus 80.11 kilojoule plus 22.91 kilojoule. So in this RHS, minus 80.11 kilojoule plus 22.91 kilojoule is minus 57.2 kilojoule. So the next step will be W is equal to minus 57.2 kilojoule. Okay. So the total amount of work done in moving the piston through a distance of 0.8 meter is minus 57.2 kilojoule. So this brings an end to the explanation part of this video. I hope you all would have understood. If any doubts are there, please do comment in comment box. And remember to like, share and comment on our videos. Thank you, friends.